This conference will now be recorded.
Hello everyone, good evening. I hope my voice is audible to you. Okay, so I'm going to discuss today about the code book, that is IS 13920, the type detailing of the RCC structures. That is the most important point. Give any detailing after design. Let's continue over here. So in this code book, what we are going to learn, we are actually considering the beam column ductile detailing. So what happens? This is my column. This is my column. This complete part is my column, and this is my beam. So we are going to give the reinforcement, the column to the beam. Now this is not the proper arrangement of the reinforcement. This is just to show how the beam reinforcement, top and bottom reinforcement, is going to act inside the column. How it is going to join at this point of joint. So what is actually happening? Beam column, beam column joint, yeah, over here. Beam bottom reinforcement is going inside the column reinforcements, and it is taking a 90-degree turn, that is perpendicular, and the top reinforcement is going bottom, taking 90-degree turn. Okay, so now this is what you have to make it in AutoCAD. So fine, this is what you have to make it in AutoCAD. So here you don't have to worry about the anchorage or the longitudinal beam bars. You have to actually keep this thing in mind. It is going downwards and this is going upwards. Okay, one rule about this, about for making the detailing of the beam column plan in or beam column section in your AutoCAD file. Okay, let's next. Now this is known as ties. So there are different ties. There one leg, two leg, four leg, six leg, eight leg. So this is nothing but your two leg tie. In front of you, you are able to see this is your two leg tie. So now two leg tie, earlier it was used to be 90 degrees like this, not like this. In this format, how this is how it has been shown. This is my tie of the column. So it is used to be like this earlier in this format. As the earthquake intensity has increased, so we have given it as 135 degrees. Earlier it used to be 90 degrees. And there are different types. I will be explaining to you how and when to use in the next few more course if it is possible. Otherwise, for G+1, this is well and fine. We will use that is two leg ties. Okay, or we can call it as stirrups or ties, in depends on the column and uh, beam. In beam it is called as stirrups, and in column it is called as ties. This is to prevent against the reinforcement. This is to prevent the structure to fail against the shear failure. Okay, now the most important component in a building is a column. Column is the strongest member of the building. If column fails, building is going to fail, definitely. So you have to make the column so strong that it will sustain the buckling. For sustaining buckling, we have to use this transverse reinforcements in beams. Okay. Now next, what you have to remember for the from this code book in the beam part is beam shall be preferably have width to depth ratio, okay, more than 0.3. This is the beam width and this is the depth, beam depth. Okay, so now width to depth ratio should be more than 0.3. That is what you have to keep. Like if width I'm giving it as 300 mm, okay, and I'm going to give the depth as 400. So is this type of beam possible? That we can we consider this type of beam? So let's check it out. So if we see after calculation, what we are getting is 3 by 4. that will be 0.7, something like that. So yes, this combination is possible. So what I mean to say, this should be my width and this should be my depth. That is what it means. Okay. The beam shall not have width less than 200 mm. One more thing, this width should be always greater than or equal to 200 mm. Always. So while designing, you have to keep this thing in mind. Or while drafting, you have to keep these things in mind in AutoCAD. Okay, we'll see to it. Next part of it is beam shall not have a depth d more than 1/4 of the clear span. This is the most important line. The next part is not required for you now. Just keep this thing in mind. So beam shall have depth more than 1/4 of the clear span. So this is the depth of the beam. This is the clear span. Clear span is nothing between the beam between two columns. So column is like continuing from here like this, and from here also the column continuation is there. So likewise, the beam in between the columns or like on the column, or it is going to be definitely it is going to go inside the column beam. So what happens? This is the clear span of the beam, and the total span will be from center of this column to the center of this column. This will be a effective span. Okay, well, let's not talk about that. So what happens? Beam depth. This depth. I'm talking about this depth. Beam depth should be 1/4 of the clear span. Imagine my clear span is 1000, 1 meter. Imagine 1 meter. So 1000 mm. 1000 by 4 will be how much? For let's take it as 1200 for easy calculations. So it will be 300 mm. So 300 mm beam shall not have a depth d more than 1/4 of the clear span. That means you should not give the beam depth as 300 mm. This is what it means, that 1/4 of this clear span, that is 1200, 300 is coming the value. So now you have to shall not have depth. So 300 mm, not more than 300 mm you can give. So now you have fixed with your beam depth to be 300. I'm just giving an example, but exact value you can take. Okay. Next part of it is 6.2.1 clause. The longitudinal reinforcement in beam shall be given as below. Beam shall have at least two 12 mm diameter bars at top and bottom faces. That means this beam must be having the reinforcement arrangement in this format minimum. Means this is I'm talking about all through. All through means throughout the beam. If this is my beam, imagine if this is my beam, and these are the two reinforcement. That's the section view I'm showing to you. On the section view, will have the section we will not be able to see the other reinforcement that is of that side of the beam. So this will be the reinforcement all through. That is 12 mm diameter reinforcement should be given at the top and as well as at the bottom. These two reinforcement that must be there. That also depends on the design criteria, how it will change and how you are going to alter those values. The minimum diameter of the link is nothing but your stirrups in the beams, and in columns it is the ties. So the link between these two main reinforcements is to be minimum of 8 mm diameter. You must remember it. 8 mm diameter. Stirrups not less than 8 mm. In some cases people give it as 10 mm, depends on the design criteria. Now next part, the first link I just now told you. Link is nothing but your stirrups. The first link shall be at a distance not exceeding 50 mm from the joint face. That means this is my joint, beam column joint. It should be 50 mm maximum. It should be 50 mm maximum over here. You have to look over here. In this complete diagram, just focus over here. So the first stirrup will start less than 50 mm distance from the column and beam joint. Now next part is splicing of longitudinal bars. Splicing means nothing but you're overlapping. Okay, overlapping one over the other. Bars kept one over the other. Okay, so when adopted, closed links shall be provided over the entire length over which the longitudinal bars are spliced. Okay, what is that? The spacing of these links shall not exceed 150 mm. That means when you are overlapping the two main reinforcement bars, you should not have the stirrup distance more than 150 mm. It should be is equal to or less than 150 mm. That is nothing but your ties or stirrups at the time of lapping or splicing longitudinal bars. Longitudinal bars is nothing but your main bars, main reinforcement bars. Okay, this part that you are seeing over here, these are nothing but your extra reinforcement bars. Okay, we'll see to it later. Next part of it I will show you in the AutoCAD file. Now let's get back to the AutoCAD file. Okay. Over here in this AutoCAD file, you can see this is what I have made the longitudinal section of the plinth beam. So I told you this is beam column joint, and you have to give the beam reinforcement perpendicular downwards and then perpendicular upwards, like this. And it is going very deep in that column. So you have to make it perpendicular downwards and perpendicular upwards. This I'm talking about this line. Okay. Now here you can see two 12 mm dia rods have been given all through. All through means completely throughout the beam. It will be completely throughout the beam. Like this, I'll show you. This is nothing but your all through reinforcement, if you are able to see. Now, why am I giving this U-turn at this end and why am I not giving U-turn at this end? Because this is actually the end of one side of the beam that is ending on this column. Other is like continuation. Other is like continuation. Now, there will be a lot of columns ahead. So beam is going to continue with this column also and again further also. So for this column, there will be no U bending, and it should be always at the end of the bending that U turn. Okay. So now we are going to provide two 12 mm dia all through at the bottom as well as at the top, all through, completely throughout the beam. Okay. Now we are going to give the uh, extra reinforcement bar according to design criteria over here. That is 112 mm dia. We are going to provide extra reinforcement. How you are going to identify this is your extra reinforcement? You have to just make it a line like this to show that it is the extra reinforcement. It is the section view of the beam. Okay. Again, we have to provide two 12 mm dia bars all through, and we are going to provide two 12 mm dia exterior. Now, two 12 mm means it from the section view you will not be able to see the other side. Definitely, we are going to place two more reinforcement over there. This is nothing but your two reinforcement. So what we are doing, we are actually providing extra reinforcement at the end over here, right end, and we are going to provide extra reinforcement at the bottom of the beam. Okay. Now we are going to provide the stirrups. So stirrups, I'm going to give it as 8T. According to design, I will tell you design data will be given to you by the structural engineer. It will be in this format. See, 8T 125 center at the support. So see, let's check it out. This is my support. So we are going to give 8 diameter, 125 center distance, the stirrups. And it should not start from 50 mm, leaving the 50 mm distance. So I'm just keeping it from start itself. Where your stirrups from start at the beam end itself, not giving any distance actually for design. Yes, so 125 center distance and the supports. See over here, there is also support where at which column is there. So we are going to provide 8 mm dia rods, 125 center to center. Okay. Let's understand one more thing. At the center, we are going to give 150 mm spacing of the ties. So we are going to give the 150 mm spacing at the ties at this center point of this beam. That is what we have to provide. That's it. Okay. Now I will be explaining to you what is the 0.15 distance L, and here also 0.15 distance L length. L is nothing but the total length of the beam. Then over here 0.3 L and over here 0.1 L. I will be explaining to you what does this mean in the next class. But for understanding today, just focus over here. 0.1 L, that is 0.1 L distance. It will be starting. Stirrup is going to start from the edge of this column and beam joint, and it is going to extend up to 0.L length, complete length into 0.L times. Matlab, if the length of the beam is 1200 mm, or just for example, so 0.1 of 1200 mm is equal to 120 mm. So till there we have to provide the top extra reinforcement. This is your extra reinforcement that we need to provide over here at this distance. And at the bottom, we should keep the distance at 0.15 L distance. We're going to give this extra reinforcement. Okay. Similar to that, from another side, we have to provide 0.25 L distance of the extra reinforcement at the bottom. We have to keep that distance, maintain that distance, and on the top, 12 extra reinforcement that we are going to give. So that should be at a distance from this support is 0.3 L distance. Okay, so this is how you have to understand the beam detailing in the section view. And now let's go for the plan of the cross section view. The cross section view, I just now told you, we have to provide 212 mm dia bars all through completely throughout the beam, and 212 mm dia bars completely throughout the beam. This is the basic rule you must provide always. Now, apart from that, what else we are giving? We are actually providing 212 diagonal extra bars reinforcements at the top, and one extra reinforcements at the bottom. This is how you have to explain, cut the section and show it to them. The section deals about this. So here only you will be able to see the top reinforcement that we are going to give, two extra reinforcements over here. And at this section YY, we are going to cut and see. So what we are going to see at the bottom, we are going to give one extra reinforcement. This is your beam section complete detailing of it. The same way it is repeated here, typical longitudinal section of beam 1. Typical means it is being repeated over here also. The plinth beam will be repeated at the first floor also. This is what it means. So we'll be making it by taking this the design criteria. I will change some values over here and I will explain to you how to make this draft in the next class. So I hope this is clear to you. And tomorrow we are going to draft this beam with the details given to you in the box and by taking help of this code book. Okay, any doubts till now? You can ask me now. You can ask the doubts, whatever you have. Now, hello. Hello.
Yeah, Roshan.
Okay, yeah, man. Are you able to understand?
Hello.
Yeah, are you able to understand?
Yes, but yeah. I want to practice that. I want to check previous matches.
Yeah, okay.
So one by one.
Fine.
Whether it is first match or second match.
Okay, okay. So these are the things I needed to explain to you. Okay, for today. Acha.
Okay.
And one more thing, Manjeshkar
Okay.
asked me. Yeah, Manjeshkar asked me one more thing. Like why we need to give 135-degree shear reinforcement. Why we have to give only 135 degrees reinforcement there. So for that, I will be explaining. If the screen is visible to you all guys, you just tell me.
Yes.
Okay. So let's go back over here. This shear, yes, this reinforcement part over here. So okay, let me